Assalamu alaikum wa rahmatullahi wa barakatuhu. This is the a video lesson for General Mathematics, Module 5, Logic. And the most essential learning competencies that we are going to discuss today are illustrate and symbolize propositions. You have to be able to distinguish between simple and compound propositions, perform the different types of operations on propositions, determine the truth values of propositions, illustrate the different forms of conditional propositions. And I think hanggang dyan lang tayo for this quarter. So for General Mathematics Module 5, you're only going to accomplish the activities for Lesson 1, 2, and 3. Okay, so moving forward, logic actually, guys, has been around for a long time. So logic has been studied since the classical Greek period, around 600 to 300 BC. The Greeks, most notably Thales, were the first to formally analyze the reasoning process. Aristotle, 384 to 322 BC, the father of logic, and many other Greeks searched for universal truths that were irrefutable. Actually, ang daming Greek philosophers at that time, and they were basically contemplating on different things that's happening in their environment, in the world, and the thought process, yung reasoning process, yun yung pinag-aralan nila Thales, at nila Aristotle. That is why they became most notable philosophers that were the foundation of logic. A second great period for logic came with the use of symbols to simplify complicated logical arguments. George Boole, 1815 to 1864, is considered the father of symbolic logic. He developed logic as an abstract mathematical system consisting of defined terms, propositions, operations, conjunction, disjunction, and negation, and rules for using the operations. Actually, George Boole, because I have been telling you that I am a computer science graduate, and George Boole is like one of the great mathematicians that has influence and one of the foundations of computing, because he created the Boolean algebra, and he used symbols. And by the way, remember that it's just true or false, itong logic. The truth values are either true or false, which is in digital computing, it just pertains to 1 and 0. And I have told you before that the machine language, the language of the computer is actually 1 and 0. So dito, isa ito sa mga foundation, I should say, ng computing, So anyway, moving forward. So what is now a proposition? Because we are going to study logic, then therefore we should know what is a proposition. So a little bit of a review for or about, I should say, the different types of sentences. So we have declarative, we have interrogative, and we have imperative and exclamatory. Why is it relevant to review the different types of sentences? It's because a proposition is a declarative sentence. Okay? So you have to be able to know kung ano ang declarative sentence, and I know that you know that. And a proposition is a declarative sentence that is either true or false, but not both. Okay, so notation variables are used to represent propositions. The most common variables used are P, Q, and R. If a proposition is true, then its truth value is true, which is denoted by T. Otherwise, its truth value is false, which is denoted by F. So let's try this one, guys. Let's see if in this activity we will be able to answer which one is what do you call this one? A proposition. So this one, the first one, Rodrigo R. Duterte is the president of the Philippines. This is a declarative sentence, and you can prove it to be true or false. So yes, this is a proposition. 6 times 6 is equals to 36. This is a proposition. The number 4 is even and less than 12, a proposition. Ouch! No, because it's an exclamatory sentence. And then what time is it? No, because it's an interrogative sentence. X plus 2 is equals to 4. Although you can argue that this is this can be proven to be either true or false, but at the moment, no, at this specific moment, we cannot prove this statement to be either true or false because we do not know the value of x. And remember, x is a variable, so meaning it can have, or it can be assigned with different values. So meaning at this certain point of time, we cannot say if it's true or false. Okay, so no, this is not a proposition. And the other one as well, as you can see, both of them are variables, so again, this is no. And then this one, Shera's solution is incorrect. This is not a proposition, this is a paradox, no, because it is neither true or false. You have to check the solution if it is indeed incorrect. Because just like example ko sa inyo dati sa math, di ba, like isang problem, pero maraming solution. And itong mga different solutions na to can come up with correct answers as well. So, iba-ibang approach, no? So, just like this one, there is no way yet of knowing if this statement is true or false. We have to check first the solution. Okay? And then number 9, Aliyah is passing statistics. This is a proposition. And then number 10, Aliyah is passing statistics, but she is failing in 21st century literature. This is, again, a proposition. Okay? So definition number 2, we have the difference between simple proposition and compound proposition. A simple proposition is something that conveys, a proposition that conveys one thought with no connecting words. Parang lang din siyang simple sentence, you know? Like, for example, 2 is an even number, a square has all its sides equal. So that is a simple proposition. Ang compound proposition naman, it contains 2 or more simple propositions that are put together using connective words, just like compound sentences. Okay, so for example, this one, 11 is both an odd and prime number. This entire statement can be dissected into two propositions, I should say. So it can be 11 is an odd number and 11 is a prime number. Okay? So, ang connectives na usually na ginagamit, guys, para sa mga compound propositions are and, or, nor, if, then, yun ang mga usual na ginagamit natin. So, if you see a proposition na merong ganito, obviously, it is a compound proposition. Okay, now moving on, let's go to the... Okay, so basic logical connectives, we have actually 5 of them. 1, 2, 3, 4, 5. So the first one is negation. Then we have disjunction. We have conjunction. Conditional. And then biconditional. Okay. So, isa-isahin natin itong mga connectives na ito. These are actually the operations that you can do within a proposition. Number 1, we have negation. If you have a proposition P, you know, for example, if you have a proposition P, negation will entail that you are going to negate the proposition, or you will say that it is not P. It is not P. So, for example, if you have a proposition P which says, she is smart, kunwari, no? Smart. Okay? If you say negate P, or not P, then that entails to she is not smart. Or sometimes, a phrase such as, it is not the case, no, that, yan, ginagamit nila, or it is false that, ginagamit din yan. So you can say that P, for example, you have a proposition P and it is she is smart. If you say not P, you can also say it is not the case that she is smart. No? But the basic one is just input not within the proposition. That is how you negate. Okay? Next, we have number 2, which is, unahin ko muna ang conjunction, ha? Conjunction naman, unlike negation, na kung saan pwede mo siyang gawin with just one proposition, conjunction and the remaining basic connectives, logical connectives, kailangan meron siyang dalawang proposition. So let's say you have a proposition P and proposition Q. Conjunction entails that there is an and between this compound proposition, or these two propositions, I should say. So P and Q, or in symbols, it is P, Q. Ang symbol ng and is like this, yung symbol ng para sa exponential, no? So anyway, let's say for example, I have a proposition P. Jethro is a boy. And we have proposition Q. He is a grade 5 pupil. Now, when you say P and Q, it entails to Jethro is a boy and he is a grade 5 pupil. Okay? So that is conjunction. How about disjunction? So number 3, we have disjunction. Disjunction is the opposite of conjunction. And the connective being used in this one is or. So if you have P, proposition P, and then another proposition Q, it will be P or Q. Or in symbol, it is P, Q. But the symbol is like a small letter V. So ang pagbasa pa rin dyan is P or Q. So let's say I have a proposition P, which is, let's say, she is a good writer. And then, let's say Q, she loves to play volleyball. For example lang, no? So if you're going to have P or Q, then the statement will be, she is a good writer, or she loves to play volleyball. Okay? So that is how you create a proposition using disjunction. How about number 4? Conditional. Conditional statements or propositions are also sometimes called implication. Implication, pag may makita kayo sa book, no? And the connectives that are being used here is if, then. Okay? In this specific connective, itong conditional, P is going to be defined as the hypothesis or the antecedent. And then your Q is going to be the conclusion or the consequent. Dahil nga sa kanyang nature, which is if and then. It's like a cause and effect situation. So this proposition entails that if P, no, ganun siya, if P, then Q. Or in symbol, that is P, if P, then Q. Okay? Or merong ibang books na ang symbol nila is ganito, P, then Q. Okay? So either way, that is the same. So let's say, for example, let's say ang P natin is, there are a lot of gray clouds. Q, it will rain today. So your P implicating Q will then look like if there are a lot of gray clouds, then it will rain today. Okay? So next we have The last one that we have for the basic logical connectives is biconditional. Now, biconditional is what we usually refer to as if and only if situation. And I'm sure you have heard this in a lot of your mathematics subjects before. So, if you have a proposition P, if and only if Q. That's the only time that it will be a true claim. At ang symbol nito is P, like this, Q. So, biconditional siya. Unlike sa conditional na P goes to Q, no? Pero ang biconditional is, it should be both ways. Okay? Or sometimes, ginagamit din ito, no? But, this is the usual symbol for biconditional. Also, in the conditional, very specific ang role ng P at saka ng Q, no? Guys, remember, P and Q are just representation of a proposition, ha? Huwag malito. Okay. So, anyway, unlike doon sa conditional, ang P at saka ang Q ay specific. Ang P ang iyong hypothesis, ang Q ang iyong conclusion. In biconditional, both P and Q are called the components. Why? Again, because it goes both ways. Okay, later on, makikita natin yan sa kanilang truth tables. Okay? So, let's have this one, an activity. Asan na ba yun? Itong activity na to, no? Convert. Try to convert. So, if you have a proposition P, which means Facebook is a source of information, and then you have a proposition Q, social media spread fake news. So, what is going to be the symbolic proposition for letter A? Facebook is a source of information and social media spread fake news. So, that is, ang letter A natin is, let me go down here. This is activity 1.3, convert. So, ang number 1 is just P and Q. Tama man? How about number 2 or letter B? Facebook is not, okay, Facebook is not a source of information and social media do not, or social media do not spread fake news. So the answer for that is not P or not Q. How about number 3? Letter C. It is not the case that social media spread fake news and Facebook is a source of information. So, nagkabaliktaran, no? It is not Q and P. So, it is not Q and P. Ang number 4 naman natin, if Facebook is a source of information, then social media spread fake news. So, that is P. If P, then Q. Conditional. Last, social media spread fake news if and only if Facebook is a source of information. So, this is Q and biconditional to P. Okay? So, I hope you understood that. Next, let's go to lesson 2, which is, okay, meron pa palang isa dito, no? Although, given na yung answer dyan, so I hope you can try to investigate and observe kung paanong nangyaring ganito ang answer, no? Ang solution. But I'm sure you can understand that. So, moving forward on truth tables. Okay. Balik tayo dito sa taas at lagyan natin ng truth table ang bawat basic logical connective natin. Now, for negation, again, no, i-remind ko lang kayo about the exponential function, yung ganyan, diba, no? Just like in, what do you call this one? The binary language of computing or computers, itong 2 na ito is representing the 1 and 0. So remember, in the logical, in logic, diba, ang kanyang truth value can only be true or false, which is like 1 and 0. Tama, diba? So whenever you create a truth table, kailangan mong ilagay dito sa X yung number of propositions. So that you will know later kung ilan ang kailangan mo na values for your truth table. Okay? So one of the, what do you call this one? Again, no, one of the basic concept of using logic in computing is that it looks like the binary language, di ba? Tama man. And for example lang, everything that you do right now, ano, foundation ito siya guys, itong logic. Like for example, pag mag-login kayo sa Facebook, no, let's say, you're going to enter your username and then your password, no? And then merong server ang Facebook ng kanilang database, okay? Database ng server ng Facebook. So pag send mo dito, no, pag enter mo ng login, kailangan niya munang i-check kung mag-match ang nilagay mong username at password sa nakasave doon sa iyong account sa database ng Facebook. Now, it will ask, no, like for example, username match true or false. If true, anong mangyari? If false, anong mangyari? And then the computer will also ask, password match? Tama ba? Nag-match ba? Again, true or false, no? So, kung true, i-log in. Pero kung false, sabihin niya, invalid password, no? So, as you can see, this is almost the same thing as all of this. So, logic is actually one of the basic foundations on how computing was able to paano na tawag dito, invent or na formalize ang computing. So anyway, let's build the truth table. So dito sa negation, you can use it in just one proposition, right? So 2 to the power of 1 is just 2. Tama? So you will have, or you should have, 2 values here, which is true and false. Okay? Now, if you are going to negate this, ang negation is just opposite. No? Negating. So if this is true, ang opposite niya is false. And if this is false, then opposite niya is true. That's how simple it is for negation. Let's go to conjunction. Conjunction is and, okay, at dalawa na ang proposition niya. So 2 to the power of 2 is 4. Therefore, you should have 4 values here. It should be true, true, false, false. Okay? And then for your Q, true, false, true, false. As you can see, yung partnership nila, yung pag-pair up nila, nakukuha nila lahat ng possible scenarios. Okay? Kung true ba ang P, what if true ang P, and then true din ang Q, or what if true ang P pero false ang Q, what if false ang P pero true ang Q, you know, it gathers all that scenarios, okay? Na-pair up niya. So if you are going to get P and Q, the ruling in conjunction is that the only time that the statement is going to be true if the proposition P and proposition Q is both true. Okay? So, ibig sabihin ganito siya. Bakit? May false man dito. May false man dito. And then this one is both false. So, ibig sabihin, this is the truth table of P and Q. The only time na magkakaroon ng truth value is that if P and Q are both true. Okay? Ang disjunction naman is different. No? Or I should say, a little bit kabaliktaran ng conjunction. Sa disjunction naman is basta may true dyan, true na gidna siya. Okay? So, true. Diba? True ang P, false ang Q, pero may true. So, true. False ang P, pero true ang Q, and then true. Both false. Okay. So, kabaliktaran siya ng conjunction. The only time na mag-false ang disjunction is when both propositions are false. Okay? For conditional, it's a different thing. So, gawa muna tayo ng table. True, false, true, false. Okay. So, for conditional, the truth table will be the only time it will have a false value is when your hypothesis is true, but the consequent is false. No? It doesn't follow. Okay? So, meaning, the truth table should be true, false, true, and true. Okay? Meron kasing time, guys, na mali yung hula mo, but the conclusion will be correct. Okay? There are times, no? May ganun pangyayari kahit sa totoong buhay, no? Like, for example, like this one. there are a lot of gray clouds, it will rain today. Let's say, for example, that proposition P is incorrect. Okay? Like, let's say, there are not so many, no? Wala masyadong gray clouds. But then, it still rain. There are times na nangyayari yon, di ba? Tama? Although, wala masyadong, gray clouds. But then, it did rain. So, it means that it can be true as well. So, the only time na magkaroon ng false truth value dito sa P, conditional Q, is when the hypothesis is true and the conclusion is false. Okay? Sa biconditional naman, it's a little bit different as well. Although medyo, medyo kamukha niya rin yung nandoon sa, tawag dito, conditional. Ang sa biconditional naman, since it's biconditional, it goes both ways. Dapat pareho sila ng truth value. Sakalang magiging true kung pareho sila ng truth value. Okay, let me use a different color. Okay. So, kung hindi na sila pareho, ng value, ang P at saka ang Q, ang dalawang proposition, hindi pareho ng value, that's the time that it will become false. Okay? But if they are the same, that's the only time that it becomes true. Hindi natin napag-usapan dito, pero meron pang isang, tawag dito, connective, which is exclusive or. Exclusive or. Okay? And I will just tell you the truth table, although wala akong maibigay masyado na example because I cannot think of an example of this right now. So, ang exclusive or is kabaliktaran ng biconditional. The only time that it will become true is if hindi pareho ang ang truth value ng P at ng Q. Okay? So, ganyan siya. Kabaliktaran siya ng biconditional. That is exclusive or kung magtutuloy kayo ng computer science, it looks like that. XOR. Okay? So, anyway, moving forward. So, that is, or those are the truth tables of each, tawag dito, basic logical connectives. Okay, so the truth table displays the relationship between the possible truth values of different propositions. Actually, nandito na yan lahat sa nyo guys, sa module ninyo. You just have to read them. Let's try this activity 2.2, truth tables. And by practice guys, kung mag-practice lang kayo, masasanay din kayo maggawa-gawa ng truth table. What was that? 2.2 truth tables. Okay, so let's try number 1. Was that? Not P. Tama ba? Okay. So, let's build the truth table. Again, P, Q, dalawang proposition. So, 2 square is just 4. So, true, F. Then we have true, false. Okay. PEMDAS. No? Unahin lang din natin PEMDAS. Mauna ang dominance, guys, nandyan sa, nandyan sa, asan na ba yung dominance? Wait lang. Andito, okay. Okay, commas indicate which simple statement are grouped together, and parentheses in symbolic statements are used to tell what type of statements are being considered. If there are no parentheses, we follow the dominance of connectives by conditional, disjunction or conjunction, and last will be the negation. So, para lang din tulad ng PEMDAS, guys, meron din siyang, dominance na gina-follow. So, let's do that here. Unahin natin yung nasa loob ng parenthesis, So, kunin muna natin yung P and Q, and then later on, i-negate natin yung makukuha natin sa P and Q. So, P and Q, we know, truth table niyan is magiging true lang kung both propositions are true. Now, if you are going to negate that, it will be F, 2, true. And that is your final answer. Ito. Okay? How about number 2? Ang number 2 ay... I'll let you answer number 2. Okay. Hindi, totoo. Okay lang. Kaya nyo tong number 2, guys. Okay, sige. Sagutan ko ang A at saka B, then kayo na ang bahala sa C and D. Okay, what was that again? Okay. So, P, again, Q, true, false. Sorry. True, false. True, false, true, false. Unahin natin yung P implicating Q, and then later on yung ganyan, and then i-end natin sila later. Okay. So, P implicating Q, so true. Ito yung false. Ito yung true, true. Pag QP, tawag dito, be aware guys ha, so baliktarin ninyo. So, true, true. FT, so true. True, false, so false. And then FF is still true. Now, if you're going to end this one, remember, true lang siya kung parehong true ang dalawang proposition. So, this one and this one. So, true, true, true. FT is not true. TF, not true. And then we have TT, or true, true, true. So, this is your final answer. So, I think you can do the rest, inshallah. So, moving on, forms of conditional proposition, because there are different forms of conditional proposition. I'm sorry, what happened? Earlier, nasabi na natin na ang conditional statement ay if P, then Q. But, the conditional statement also has different forms. Pag ibaliktad mo kasi to, it's very specific kasi ang conditional statement, no? Hindi mo siya pwedeng basta-basta ibaliktad. Unlike the biconditional or the conjunction or what do you call this one? Disjunction. Kung baga pa, ang conjunction, disjunction at saka biconditional, meron silang commutative property. Maalala nyo pa yung commutative property? You know? Kahit balibaliktarin mo, it's okay. You know? The conditional statement is not like that. Okay? That is why, kung mabaliktad siya, it becomes another form of conditional statement. At for example, kung binaliktad mo ito, this becomes the converse of this statement, which is the conditional statement. Okay? Now, if you are going to differ or you negate the P, not P, and implicating not Q, then this becomes the inverse. Kasi, inverse siya because you are negating the proposition itself. No? Hindi yung kanilang order. It's still the same as this, no? It's still the same as conditional. It's just that you negated both proposition. And it becomes the inverse. Now, ang contrapositive naman, contrapositive form of conditional statement is when the inverse is conversed. Ibig sabihin, ibaliktad mo ibaliktad mo yung inverse. Okay? So, these are the different, what do you call this one, forms of conditional proposition. So, let's say, for example, I have a proposition P. I study hard. Kunwari, kasi exam nyo na next week. And then Q will be, I will pass the exam. Okay. So, if this is your propositions, the conditional statement will be, if I study hard, then I will pass. Okay? Ang magiging converse niya naman, kabaliktaran, will be, if I will pass, then I study hard. No? Although grammatically wrong siya, guys, but you can get the point. The converse should be, if I passed, then I must have studied hard. Diba? Now, ang inverse niya would be, if I don't study hard, then I will not pass. And ang contrapositive naman yan is, it will be, if I don't, or if I didn't pass, then I didn't study. Okay? So, in technicality, in layman's term, yung basic understanding natin, kung nakikipag-usap tayo sa ibang tao, all of these are somewhat the same. Diba? But in actuality, or in using the truth table, let's see which ones are actually the same. Okay, tingnan natin kung saan ba talaga dyan sino ang magkapareha dyan. Okay, so let's get P, And let's have Q. So true, true, false, false, true, false, true, false. And then let's get P implicating Q. And then the converse. And then magkuha muna tayo ng mga negation nila, no? And then let's get the inverse and then the contrapositive. Okay. So, nahin natin tong implicating because we know this already. And then ang Q, if Q then P, it will be FT true, and then TF is going to be false, and then true. Now, inegate muna natin ang P, so magiging false, false, true, true. Pag negate natin ng Q, it will be false, true, false, true. Now, if you're going to get the inverse, so ito na, no? Itong dalawa na ito ang i-implicate natin. So, false and false still true, false, true, 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 false, false, true, and true, true. Now, for contrapositive, pabaliktad. So, false, false is still true. True, false, false. False, true, true. And then true and true, true. Okay, now, ang magkapareha pala ay ang conditional statement and the contrapositive. Okay? At ang magkapareha naman ng truth table is the converse and the inverse. Okay? So, yung statement natin kanina, ang magkapareha pala dapat ay, if I study hard, then I will pass. At ang kanyang logically equivalent pala ay, if I didn't pass, then I didn't study. Nice. Okay, so that is the, what do you call this one? The different forms of conditional proposition. And when you look at this, guys, sorry, since pareho sila ng truth table, that is actually what we call logically equivalent. Okay? So, according to your module, andito na part, no? Ayan. Two propositions P and Q that have the same truth values are said to be logically equivalent and denoted by P, logically equivalent Q, or P, tatlong bar Q. So, ito siya ibig sabihin, guys. You can write this one, logically equivalent as P, 1, 2, 3, Q, or P. Guys, wag masyadong malito with biconditional, ha? Kasi ito siya, dalawang bar ang nasa gitna. Ang biconditional is ganyan lang. Okay? So, be careful then in writing different symbols. Now, according to, what do you call this one? According to certain laws, P implication Q is the same or is logically equivalent to not P or Q. So, ibalik natin sa example natin kanina, itong proposition na to. If I study hard, I will pass. So, if P implicating Q is the same as not P or Q, then it will sound like, if I do not study hard, sorry, walang if sa unahan, sorry. I do not study hard, or I will pass. So, are they the same? No? Kung isipin mo, pwede ba? No? But looking at reality, in reality, now, for example, P implicating Q, if you study hard, then you will pass. That's a good chance, right? High probability. Pero yung not P or Q, if I do not study, if I didn't study hard, or I will pass. There are times, di ba, na nangyayari yon. Kahit hindi ka nag-study, nakapasa ka. Di ba? There are times na nangyayari nun. But that is just us, you know, that is just us trying to contemplate if they are really indeed the same. But let's try and look at their truth tables, no? Para makita talaga natin kung they are technically, logically the same. So, P, And Q, we have true, true, false, false. And then we have true, false, true, false. Okay? And then, alam natin ito. Mag not P tayo dito. Kailangan natin ng negation. And then, later on, or natin siya with Q. So, ito muna. Alam na natin to. This is true, false, true, and true. Ang not P is false, false, true, true. And then, that is this one. Ito na yung ating i-or sa Q. So, true, false. Basta may true. True na gitna siya. False, false. That is false. True, true. False, true, true. Okay, so apparently, they are indeed the same. Okay. So, the meaning of this is that seemingly, if you're just going to hear the statement of other people in real life on a day-to-day basis, we feel as if they don't mean the same thing. But in reality, they do mean the same thing. Okay? So, that is a little what you call this one, nuisance in using logic. Sometimes nga nakakapag-overthink na ang mga tao because they know logic and they are trying to apply it into their lives. But there are also advantages. Like if you're really good in logic, you know, you can get away with things and you have a lot of times that you can, you know, win arguments or debates or whatnot. So moving forward, observe. Are we going to observe this one? Okay. Let me solve this one, itong number 3. Kasi feeling ko kaya nyo yung 1 at saka 2 eh. Itong number 3 lang ang isolve ko for you guys. Okay? Let me solve that one, which is activity 3.2, no? Activity 3.2, observe. Number 3 lang ang sagutan ko because I know you can do number 1 and 2. So, P or Q, what? Q and R. Tapos, tignan natin kung equivalent siya sa P. Ano yan? Or Q. And P or R. Okay. Tignan daw natin, no, kung equivalent pa talaga sila. Now, we have R. So, 2 to the power of 3 na tayo. So, 2 to the power of 3 is just 8. So, meaning, dapat meron tayong 8 values dito. Baka hindi mag-cash siya. Let me. So, dapat true, 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 true. And then false, 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 false. So, for Q, you have true, true, false, false, true, true, false, false. And then for R, you have true, false, true, false, true, false, true, false. Now, as you can see, guys, nakuha niya na lahat dyan ng scenario na pwedeng, no, yung possible combinations ng mga propositions na ito. So, unahin natin ito, no? Q and R. Okay? So, Q and R and true, false, 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 true, false, false, false. Tapos, i-OR natin sa P. Okay. Pag OR natin sa P, so, ito siya na part, guys, ha, ang i-OR natin sa P. So, true and true, true, true and false, true, true and false, true, true and false, true, false and true, true pa rin, false and false, false, F, 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 okay. Now, moving forward, ito naman, no, itong part na to. So, P or Q, and then, kailangan din natin ng P or R, and then later on, silang dalawa ay i-end natin. Okay. So, P or Q. True, 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 false, false. Okay. P or R. So, true again. True. True. True pa rin. True. False. 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 Okay. Now, if you are going to end this two, ito at ito, so, end. True. 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 True, true. Kahit may true dito, may false dito. So, false pa rin. False and false. So, as you can see, apparently, they are logically equivalent. So, the answer for number 3 is that they are indeed logically equivalent. Okay? I'm sure that you will be able to answer 1 and 2. Kasi nga, ito lang yung mahaba na part, diba? So, I know you can answer that one. Let's proceed to De Morgan's Law. De Morgan's Law are actually two statements that are the same, that are logically the same. Okay, baba ko lang konti. De Morgan's Law. And De Morgan is also one of the great mathematicians who are the foundation of computing as well. So, meron siyang dalawang statement dito, which is apparently not P or Q, and Q is logically equivalent to not P or not Q. And the second statement is not P or Q is logically equivalent to not P and not Q. Okay. Kung titingnan lang natin siya or kung isosolve natin siya, no, like we are going to use concepts from algebra, itong negation is like negative, 'di ba? So, kung i-distribute natin to siya dito sa loob, no, it will become not P at saka not Q. But this one, babalik ta rin natin yung kanyang connective because nga, ginigate natin tong dalawa na variable. Just like, tawag dito, ano ba, 4x plus 2 minus 5x plus 1. Di ba pag i-minus natin yan siya, itong negative, di ba, i-distribute man natin yan siya dyan? Tapos ang magiging labas niyan, di ba, is 4x plus 2 minus 5x minus 1. Di ba? So, aside from distributing the negative, gibaliktad na rin natin ang kanyang operation. No? So, parang ganon ang effect ng De Morgan's Law. As you can see, itong not P or not Q is the same as this. Ano? But, let's try to prove this law using the truth tables if they are indeed the same to one another. So, i-prove muna natin itong isa. Itong nasa taas. Itong statement 1. Let's say we have a P, a proposition P. He is smart, kunwari. No? And then, ang ating Q ay, since he is smart, let's say he is an honor student, an honor student. Okay. Okay. So, when we say this one, no? Unahin natin tong part na to. It will sound like it is not the case, kasi may negation, no? It is not the case that he is smart and he is an honor student. And apparently, that statement is the same as he is not smart or nor, no? Kasi nga or ito, so nor he is not smart, nor is he an honor student. Okay? So, they are the same, right? In all technicality. Do you think I should write it down? Okay. So, let's say ito, no? So, if this is the case, so it is not the case that he is smart and he is an honor student. And apparently that is the same to not P or not Q. So, he is not smart, nor is he an honor student. So, technically, di ba, kung iisipin mo, they are, yeah, the same. Let's try, no, giving out or giving an example for the statement 2. Let's say I have a proposition P, which is, she is good in English, let's say. And then, ang Q ko is she is good in writing poems. Ganyan. Okay. So, using this one, itong nauna, ano, itong not P or Q, it will be, it is not the case that she is good in English, or she is good in writing poems. Okay. Ang kanyang kabaliktaran naman, sorry, hindi kabaliktaran. Ang kanyang equivalent naman is apparently this one, which is not P and not Q, which will sound like she is not good in English and she is not good in writing poems. Okay? So, looking at the examples, they are similar, no? In context and meaning, it's similar. It is indeed similar. But, let's try to prove De Morgan's law using the truth table now. At nang makita talaga natin, no? So, dito ako mag-prove sa baba, guys, ha? I-prove natin dito. Proving De Morgan's, sorry, De Morgan. Magkahiwalay kasi yan. De Morgan's law. Prove natin yung number 1, no? Itong number 1 muna tayo. So, not P or Q, and Q is equals to, or logically equivalent to not P or not Q. So, kunin natin ang P and Q. True, true, false, false. True, false, true, false. And then, kunin muna natin ang P and Q. And then, later on, i-negate natin siya. Okay? So, P and Q, true, false, false, false. Tama man? At pag i-negate natin siya, it will be false, true, true, true. Okay? Now, let's get the other one. Kailangan natin ang not P, kailangan natin ang not Q. And then, later on, i-or natin yung dalawang yan. Okay, so ang not P is true, sorry, false, false, true, true, and then false, true, false, true, and then i-or natin tong dalawang to, it will look like false, true, true, and true. So apparently, they are indeed logically equivalent. Okay, let's try the statement number 2 in De Morgan's law. Not P or Q is equivalent to not P and not Q. So, ganun pa rin. P and Q, you have true, true, false, false. And then you have true, false, true, false. Okay, kunin muna natin yung P or Q. And then later on, inegate natin siya. So, ang truth table ng OR is just true, true, and false. If you're going to negate that, it will be false, 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 true. Okay? Kunin naman natin itong sa kabila. Kailangan natin ang negation both sides. Okay, so false, false, true, true. And then we have false, true, false, true. Okay? And then i-end natin sila. So, magiging false, 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 true. Indeed, they are logically equivalent. Okay? So, baka tanungin niyo guys, teach kanina pa tayo nag-ing-ani. No? Anong ibig sabihin pala talaga ng truth table, teach? Ang truth table, it shows you different combinations in which or in which the claim could be valid or true. Okay? So because there are times, no? There are times na, like for example, this one, this disjunction, she is a good writer. That is just a proposition. It can be proven to be either true or false. Tama? So, if in any case, no, for example, if in any case you find out that she is indeed a good writer, so P is true, and then she does love, she do love playing volleyball, so that is true. Meaning, this claim that she is a good writer or she loves to play volleyball is indeed true. Okay? So, the only time na magiging false itong claim na to, itong statement na ito, is when she is not a good writer and she doesn't love to play volleyball. Okay? Merong mga ganun eh. Like for example, nung face-to-face class, like you have a proposition. Kunwari, no, ang proposition mo is, hindi nagklase si sir. So, walang klase sa first period. Kunwari lang, no? And then your Q would be, walang klase sa second period. Now, for example, if I am going to put this statement into an implication, no? So, pag sinabi mo na, if walang klase sa first period, then walang klase sa second period. Okay, so remember, ang truth table ng P implication Q is true, false, true, true. So, meaning, no, there are times that walang klase sa first period, indeed, wala ring klase sa second period. No? But it cannot be that nagklase sa first period, let's say, same teacher ha. Kunwari lang same teacher. Nagklase sa first period and then walang klase sa second period. No? That could happen, but with reasons. With specific reasons like may emergency. No? That could happen in real life, but there are now reasons. So, hindi na siya within the sole basis of these two proposition, but rather meron na siyang another reason. Meron na siyang proposition R, meron na siyang proposition S, or T, or U, or V. No? Ibig sabihin, marami ng proposition doon na part, but we are only within P and Q. Okay? So, if hindi totoo na walang klase sa first period, pero nagklase kayo sa second period, malamang late lang. Di ba? That could possibly be true again. And then, it might be the case that walang klase sa first period, no? Or nagklase sa first period kasi nga false, no? So, kung nagklase sa first period at nagklase sa second period, then that is also true. Meron pang ibang example. Like, for example, kayo dati yung gideclare na holiday, therefore walang klase. Ano? Yung mga ganong good ninyo na argument, yun ang usually, doon ginagamit dapat ang logic. Okay? So anyway, what else? I have a definition for, there you go, negation of the other connectivity. Okay, negation of a negation, or double, getting rid of the double negation. Wait lang ha. Ayan, negation of a negation. It's just, yan, ganyan, no? Because if you have P and then you not P, and then i-negate mo ulit yung not P, it's like, for example, I have here, she is smart. Yan ang aking, proposition. Pag i-not P ko siya, then she is not smart. Diba? And then if I negate the negation, it will be she is not smart. Which is basically what? Which is basically the same as P. So in reality, not P is logically equivalent to P. Okay? So kailangan pa ba natin itong i-prove ng truth table? I'm sure you already know this one, but okay, let's just prove it with the truth table. So i-not P natin siya, so false, true. And then kung i-not natin yung not P is true and false, which is the same as this. Okay? Anyway, so that is negation, double negation. Tanggalin mo yung negation. So pag may nakita kayong ganito, you just can cancel that out. Parang negative times negative lang din good. You can cancel that one out. It's just the same as P. Okay? And then we also have the other one. I think this is the last one for now. Let's see. Negation of a conditional statement. Okay. So, negation of a conditional statement. Okay. So, for you to be able to negate a conditional statement, no? Should be like this. This is equivalent to, what was that? P and not Q. So if you're going to try and prove that again, if they are indeed logically equivalent, okay, so P, if P then Q muna tayo, then mamaya, kailangan ko ng not Q and then P not Q. Okay. So P, if P then Q, it will be true, false, true, true. And then pag i-ano natin siya, in not, it will be false, true, false, false. Ang not Q naman is false, true, false, true. At pag i-end natin itong not Q sa P, it will be false, true, false, false. Okay. Indeed, they are equivalent. Now, you might ask, teach, bakit kailangan natin i-prove itong mga bagay na to? That is actually because later on sana, no, sa susunod na lessons, pero too bad, hindi na natin siya matakel. But later on sa lessons, you will be proving a lot of things. Tautology na kasi, no, tautology and syllogism na yung susunod sana na mga lessons. In which case, you are going to prove the validity and the truthfulness, no, ng isang argument. It might be a valid argument, or might be a truth claim, or it might be a fallacy. Mali siya. No? So, yun sana yung susunod. Kaya kailangan, sana, alam nyo tong mga bagay na to, and you know how to prove things, because later on, no, yung mga susunod na lesson, you will be proving a lot of tautologies and syllogisms. Ang ibig sabihin lang naman ng tautology, guys, is a proposition that is always, it is always true. Like, ang buo niyang truth table, yung itsura niya, is true lahat yan. So, any scenario, ibig sabihin, it is always true. Okay? Yun ang ibig sabihin ng tautology. Sayang, hindi natin naabot, no? Pero sige na lang. Itong mga ganitong klase, guys, like, it can either be false or true. This is what we call a contingent. Okay? Ibig sabihin, contingent yung iyong claim. It might be false, it might be true. Pag tautology, it is always true. Now, merong kabaliktarang tautology, contradiction. Ang contradiction naman is always false. So, false lahat yung kanyang truth table. Guys, na ano siguro tayo, no? Wag niyong isipin na ganito lang yung truth table. As you have already seen earlier when I was proving which was ito no, itong part na to. Merong R, no? So, pwedeng ganitong kahaba ang truth table. And I have seen computer engineering students before who have, wow, amazing, who have P, Q, R, S, T, U, V na mga propositions like what? Grabe guys ang ginagawa nila. Like, feeling ko kami ng mga computer science hanggang dito lang kami. Or sometimes siguro nandito. Pero sila, grabe. Like, kulang na lang ata Manila paper yung gamitin nila para mag-prove ng mga bagay-bagay. But anyway, kung masusubukan nyo ito guys, pag meron na kayong discrete mathematics or logic and switching theory, if magtuloy kayo ng computer science, computer engineering, electrical engineering, electrical communications engineering, you know, those are the courses that solving logical symbols of this quantity relevant, no? Pero kung hindi man lang din kayo magtuloy doon, I think it is enough that you are able to at least do this basic operations in logic. Okay? So, thank you so much for watching the video, and I hope that you did learn something from the general mathematics subject. Subhanakallahumma wa bihamdik, ashhadu an la ilaha illa ant, astaghfiruka wa atubu ilaik. Assalamu alaykum wa rahmatullahi wa barakatuhu.